Hey guys, today I will be presenting our embedded systems project, so that me and Andre implemented. It's called Hovercraft, and basically I'll tell you what it does. I'll draw a small sketch for you so it's clear how it works. So basically what we have here is we have a small casing here which houses two motors that are parallel to the ground. Let's say we have one motor here that spins. So let's say we have one motor here. Let's say we have another motor here. Let's say we have it like this, we have it like that, and then they are connected here. We have a platform here, like this, and there's a plastic bag around here. Now, when we power these two motors, they push the air down this channel and under the plastic bag like this. So what it does, it generates the lift. So this hovercraft lifts and hovers above the surface of the floor. And then if we increase the voltage on these DC motors, of course it's gonna fly higher. Now here's the thing, those two motors are just for lifting this hovercraft in air and providing some air cushion between the surface and the floor. So if we add another motor here, let's say we have another motor here that has a propeller as well, and if it's spinning, it provides thrust forward. So what happens is that it will be pushing air in this way, and this hovercraft will move in a specific direction. Here's the thing, so we can control the speed of this, and what we can do is basically we can attach a small servo motor here that basically is connected to the pad right here, and this pad, what it does is basically turns left and right 60 degrees on each side, basically directs the flow of air in a specific direction. So this hovercraft can actually move left to right. So let's say if I move this pad to the left, this hovercraft will move to the left. If I move to the right, it will move to the right. So they have a small servo motor here, which is super lightweight, and basically provides guidance for this hovercraft. Here at the front, we have ultrasonic sensor attached, and ultrasonic sensor detects if there are any barriers in the way. So if it's too close, it's going to decrease the speed of this motor, so it actually slows down before it hits. And if it's too close, it will actually reverse this motor and will actually make this air go backwards, so it will actually make this hovercraft shift backwards and come back. We also share the link to the GitHub repository, so you will have access to everything in code, what parts to need, how to build it, what are dimensions, and so on and so on. That's it. So let's move back to our lab so I can show you the model of this in real life. Here is our hovercraft, and these are the two motors that are pushing air down. Exactly the same motor attached here as I've explained already. So these two motors are lifting it up, and this motor at the back is basically to make sure that this hovercraft goes forward, or even backwards if I want to switch the direction of the airflow, right? As I explained, this is the small servo motor that is attached here. We'll demonstrate exactly how it works, but basically it rotates 60 degrees in each direction. Right to the left, this hovercraft will actually turn to the left, and we will see how it works. And if I basically turn this to the right, air will be hitting to this pad from here and reflecting back in that way in the camera's view. So what happens is it actually turns to the right. That's how we can control movement of this hovercraft. Either it goes to the left or to the right. This is a Bluetooth module here. So this Bluetooth module is connected to our joystick, so we can actually send remote requests on how to move it and what to do exactly. These two things are what we use them for is basically to implement PWM for motors, so we can control the exact speed of every single motor. So we supply the whole circuit with three lithium-ion batteries. Each one is 3.7 volts. Small device here is the power converter. So what we need is we have our microcontroller here in front. This one operates on 5 volts. The servo motor operates on 5 volts, and our Bluetooth module also operates on 5 volts. So we don't want to fry them. That's why we have a little converter here which converts 11 volts to 5 volts, so we can power our Bluetooth, or we can my microcontroller and the servo motor there. And then the last thing I want to mention is we have ultrasonic sensor in front, as I described before. So ultrasonic sensor detects if there are any obstacles in its way, and if I'm let's say too close to this ultrasonic sensor, the back motor will reverse thrust. So actually this hovercraft will go backwards. That's basically our hovercraft. Let's see it in action. So this is our joystick that we use to control our hovercraft. So here we are basically providing power through our power bank, and then it's powering our joystick. And what it does, we have a Bluetooth module connected to the joystick. and this Bluetooth module is connected to the Bluetooth module over there on the Hovercraft. So you can control the speed of the bottom two motors with this joystick, and on this side, these two buttons here are to control the speed of the motor that is behind, that is pushing this hovercraft forward, right? So with these two buttons, if you keep pressing this through PWM, the thrust that motor provides will increase, so it will actually start accelerating. And if you press this button down, if you start pressing this one, and then that speed will decrease, right? So this is for increasing the speed, this is for decreasing speed. And the same goes for here. So it's for increasing the thrust, and it's for decreasing the thrust of the two bottom motors. Do it again.
Right, so I can control the angle of the servo motor by simply playing with joystick left and right.
Go on.
So for example, and then if I were to release it, it's gonna go simply to like the dead position,
Okay.
let's say. Right, I can also control the speed of the back.
Let's go on, let's see that.
Right, so for example, it's like one of the minimum speeds, and then the more you press, the higher the speed becomes. For example, it's like one of the higher ones.
Okay, try to decrease the speed now.
Right, I'll decrease it, so it goes. Okay, I'm gonna stop it. And you can also control the speed of the bottom motors. For example, I'm gonna slowly increment it.
Go on. Thank you for watching. I hope you liked our project.